A warm hello to all my industry colleagues. My name is Melvin Matthews and I'm here to discuss what the journey towards autonomous shipping is likely to look like. For those of you less familiar, Watsala has mainly two business areas that it focuses on: energy and marine. The energy business deals with shore-based power plants which run on traditional fossil fuels, biofuels, synthetic fuels, and also powered by renewable energy sources. When it comes to the marine business, Wartsila has its machinery, engines, equipment, devices, and sensors, also digital solutions installed on roughly a third of the world's shipping fleet. It services and maintains roughly half the world's shipping fleet. It operates in almost all shipping sectors from cruise and ferry, offshore and fishing, merchant and military vessels, etc. Wartsila is a 185-year-old company. But for any company to be successful, it needs to have a vision. A few years ago, all the stakeholders and leaders came together to formulate a common purpose. At Watsala, it is enabling sustainable societies using smart technology. The company now had a purpose and needed the strategy and tools to get to its smart marine vision. It looked at three building blocks to achieve this. Firstly, to manage the shipping assets from cradle to grave. That is using data right from shipyard to scrapyard. Secondly, optimize the voyage from berth to berth. That is using smart digital solutions. Finally, to perfect the core. That is total digital transformation, starting internally, but more importantly, with all external stakeholders such as customers, partners, suppliers, ports, regulators, etc. Wartsila then embarked on a well thought of and planned acquisition strategy to enable its vision and purpose. In 2015, L3 Marine was acquired for its marine automation and DP systems. In 2016, Eniram was acquired for mathematical modeling and energy efficiency solutions. In 2017, Guidance Marine was acquired for its sensor technology. And then the following year, Transas was acquired for EGDIS, vessel traffic management, and simulator systems. If you look at the acquisitions, it without doubt points towards the direction of unmanned and autonomous shipping. This also means that there now exists the most extensive portfolio of smart marine technologies and capabilities that no one can match, which include specialized marine automation systems, world-class mathematical modeling and energy efficiency solutions, cutting-edge sensor capability, global leader in vessel traffic solutions, leading cloud service for fleet operations, world leader in bridge and engine simulations, cybersecurity as a core competence, over 300 software developers to bring all this seamlessly together. As a result, Watsala now has the widest portfolio to create and curate autonomous maritime transportation. But in order to pursue autonomy, we need to understand where the industry as a part of the larger global supply chain is headed. So what is happening currently across global supply chains? Until earlier this year, there was a great motivation for the supply chains to work on a just-in-time principle, with a strategy to minimize or even eliminate inventory. But the pandemic has shown that just-in-time can only work in an ideal world without disruptions. But in reality, supply chains need to have flexibility and resilience, which only just-in-case can provide. Just-in-case meaning not eliminating inventory, but dynamically optimizing inventory to absorb supply chain shocks and disruptions. On the other hand, cargo is expected to be monitored and tracked all the way from first mile to the last mile. This is going to be dramatically improving supply chain management, and it is impossible without real-time data coming not just from across the industry, but from all key points along the global supply chain. Supply chains can no longer stop, which means cargo needs to move 24 hours a day without the need to adhere to human maximum work hours, mandatory rest periods, human error scenarios, etc. This is only possible by going fully digital and total automation. And what we need to realize is that for an industry to transform digitally, change must happen across it, both horizontally and vertically. In the shipping industry, whether we acknowledge it or not, digital transformation has been happening subtly for quite some time, and it has happened beginning at the grassroots. So then the question arises, What has been happening at the grassroots? To begin with, on board the vessel. Remote and unmanned operations, for example, have already been happening on board for decades. Operation of machinery has moved from the machinery space to the engine control room. And I have personally been on ships where the engine control room is outside the machinery space and co-located with the cargo control room in the accommodation. On some ships, the engine control room has even been moved up to the bridge. Cargo operations are in fact not carried out from the cargo deck spaces or pump rooms, but like earlier mentioned, CCRs which are located within the accommodation. Technology to run unmanned engine rooms have been around since the 1970s. And the 1990s saw GMDSS simplifying communications, removing the highly skilled radio officers in the process. For over 20 years, data platforms on board have been able to capture data from sensors, devices, equipments and machinery on board and send it ashore, especially with the development of modern connectivity and communications capability. This leads us to the question, what changes have occurred ashore where operating and managing ships actually happen? Computerization in ERP systems have allowed uniformity across different departments. Data from various reports coming from the vessel, such as known reports, maintenance reports, incident reports, etc., are now reviewed by experts and archived ashore. Unlike in the past, analyzing data is revealing actionable insights into performance, efficiency, fuel saving, emissions, etc., while reducing delays, wastage, and failure. Digital systems have started taking into consideration today's virtual work setup and the informal information exchanges that are being missed out due to working remotely. A vast product portfolio not just allows adding value to all vessel segments, but also to ports and other parts of the supply chain. With increased sophistication of sensors and software driven by data from the sensors, it is now possible to predict equipment servicing needs, optimize repairs and condition-based maintenance. Algorithms allow running predictive maintenance to a great degree of accuracy, ensuring almost zero downtime. Performance-based agreements have enabled focusing on running vessels at peak operating performance. Increasing pressure to be efficient and regulatory pressure to decarbonize can be targeted individually at vessels while ensuring total energy management. Optimizing all aspects of the voyage is possible to ensure efficiency in operations by bringing all data sources on board seamlessly together with those ashore to avoid delays and exploit synergies. The question then arises, what does this all mean in reality? Well, the true benefits of digitalization can only be achieved when the entire maritime ecosystem is digitalized. However, if we were to just talk about navigation, in order to achieve automated collision avoidance, one needs to have situational awareness. In the future, with reduced crew or vessels being unmanned, total situational awareness can only be achieved by smart sensors and devices. Of course, when the situation demands maneuvering for collision avoidance, then we need to digitally instruct the automation that controls the propulsion and steering controls. If we were to consider activities in port, then this entails automatic mooring and unmooring, bunkering, swapping of battery power units for short sea vessels, automated cargo operations, etc. Coordination of port functions will most likely be done digitally by a remote control tower. It will oversee not just every operation, but every activity for safety and efficiency. The entire ecosystem, sensors and devices are built ground up, cybersecurity enabled, with all data stored and analyzed in a secure cloud. So what does that journey towards autonomous really look like? Obviously, ships going unmanned is not something that's going to happen overnight. Watsala has therefore taken a practical approach to this development. Autonomous solutions of the future will first be used as decision support systems by the current crew. This will give the crew and shore management early and real-world operational experience with the advanced systems. Trust and confidence will allow a smooth transition to autonomous solutions and autonomous operations. This, of course, ensures a commercially viable path towards autonomy. We have several test cases and working solutions developed in the journey towards autonomy. Many of them will lead to massive reduction in complexity of machinery and processes on board. capable of reducing manning levels and eliminating unproductive work on board. From the outset, we made a conscious decision only to engage in projects that involved co-development. This means working closely with key customers to tackle challenges in their operations. MVP testing of different solutions to these problems. The goal is always to solve problems in the current market while bringing us closer to autonomous ships. As a consequence, we have therefore developed and tested a wide range of working solutions such as remote control operations, smart maneuvering suite, auto docking and auto transit, cloud solutions to just-in-time arrival, situational awareness and collision avoidance systems, wireless charging for ships, etc. When it comes to remote control operations, we have systems in deployment since 2015, but due to strict NDA, we are unable to discuss the details in public. However, for public consumption, we remotely operated a ship in Aberdeen in the UK from San Diego in the US. We achieved full remote control functionality even at low bandwidth. The response time was less than 1 second, and in this particular use case, there was no need for class approval. The Smart Maneuvering Suite is the capability where the entire maneuvering is controlled by software, with the option of manual override by the crew at any time, of course only if required. It includes Smart Dock, which is essentially autonomous docking and undocking system, Smart Transit, which is automated transit between ports, Smart Entry, which is basically automated assistance for entering harbor, lock gates, canals, etc. These are commercially available for adoption today and bring with it the following benefits. Reduced maneuvering time, resulting in significant fuel reduction. It copies and performs like your best captain every time. Every maneuver is uniformly executed and fuel consumption therefore better predicted. Vessels spend a lot of time waiting at anchor. This is partly because ports and ships operate in silos. It is estimated that there can be an overall efficiency gain of between 15 to 30% if vessels arrive just in time based on berthing and cargo availability at the port. To solve this problem of just-in-time arrival and to optimize the ship and port operations as one ecosystem, we have developed a single secure communications platform connecting the vessels with onshore management and port operations. The Watsala Force Cloud facilitates just-in-time arrival by transparent navigational informational exchange, charter party and environmental compliance, optimization of voyage and speed behavior along with port stays. For congested waters like Singapore Straits or inside harbors, we have developed a near-field collision avoidance solution in cooperation with Singapore MPA and PSA. The entire process of development and trials was supervised and approved by Lloyd's. It is now in the works to scale the technology learnings and make it available in other major parts around the world. In the case of near-field collision avoidance, situational awareness was achieved by sensor technology based on laser, microwave radar, vision processing, GNS, etc. The result was that with the help of situations and real-life tests, we developed solutions similar to what you may find in modern cars, such as adaptive speed pilot, collision avoidance, parking sensors, 360-degree view, virtual lookout, etc. The other areas of innovation that are being worked on are in battery technology. We already have plug-in charging solutions for many years now. But a few years ago, we were the first to develop a wireless induction charging solution for ships that is commercially available now. We are also working on design and concept for slow charging and self-driving batteries. We often hear the question, when will unmanned ships be available? For your information, they already exist, but for limited operational scenarios, and we see interest, for example, from coastal ships, short sea voyages and inland waterways with transit and speed limits. Transocean vessels are expected to pursue periodical unmanning for a few hours during ocean transit in areas of, say, limited traffic. New development in special areas where certain exceptions to call rigs are being permitted. And finally, where we have seen most interest is when there is a close cooperation between technology provider, ship operator, and flag authorities. I hope this has given a high-level insight into technology developments and solutions available to tackle going unmanned. If you have any questions, please contact me and I will be happy to answer them. Thank you.